So today I'll talk a little bit more about exponents. If you watched the previous video, I talked a little bit about some simple exponential properties. So they were actually very introductory. I talked about what an exponent is, what a power is, stuff like that. So if you watch that video, you should be good, and I'm going to elaborate a little bit more about exponents today, talk about two more properties that I didn't talk about in the previous video, and we're going to look at those properties and see how they behave. So if I can find a marker, as you can see I'm always very prepared. Anyway, so just to summarize what we did in the last video, maybe that's a good idea. If we had two exponents being multiplied, or two numbers being multiplied, that were the same base, so the base is the same, base meaning the number, and what I would do with the exponents is I would add them. So this would be 2 to the 6. And for division, if I had 2 to the power of 5 divided by 2 to the power of 3, I would have 2 to the power of 2. So if I'm dividing the same base with exponents, I just subtract it, and if I'm multiplying the same base with exponents, I add the exponents. So today we're going to talk about another property. So I'm going to put it up here and see how that one behaves. So let's say I had 2 to the power of 3 in a bracket. So that's what I have. And on the outside of the bracket, I had another power. So let's say I had 2 to the power of 3 to another power of 2. So you might think that, hey, let's evaluate 2 to the power of 3 first and then square it. You can do that, but questions will ask you to write this as a single power. Now you might ask, how might I write this as a single power? Well, all you have to do in that case is you multiply the exponents. So you have to be a little bit careful here. So actually, you don't have to be too careful when multiplying. You should know 3 times 2. 3 times 2 is 6. So I can actually rewrite this as 2 to the power of 6. And 2 to the power of 6, if you punch that into your calculator, is actually 64. And just to show you that this works, let's say you evaluated 2 to the power of 3 first of all. So 2 to the power of 3, again, squared. So 2 to the power of 3 is 8. And what's 8 squared? 64. So 8 times 8 is 64. So as you can see, we can write this as a single power. So the property I really wanted to highlight here is that if you have a power of a power, that's how I remember it. Because look, I have a power and I have another power on the outside. So if it's a power of a power, what I do is I multiply the exponents. I'll just quickly put this up. So again, if I have a number inside a bracket that already has a power on it, like an exponent on it, so 2 to the power of 3 in this case, and there's an exponent on the outside as well, which there was, in this case there was a power of 2 on the outside. All I have to do with the exponents in that case is multiply them. So notice that this is an exponent of an exponent, so I multiply. You don't add them in this case because it's a power of a power. You're not multiplying two bases and adding the exponents, you're doing a power on top of a power. Except that I've said power a lot of times in this video already, but I will continue to say it because power of a power, you multiply. I see that mistake a lot where people are adding instead of multiplying. No, if it's a power of a power, all you have to do is multiply. So hopefully this is another thing you picked up. I'm going to talk about one more property. There's actually two more properties I should talk about, but I'm going to talk about one more and get to some problems that we can solve with the properties we've learned so far from the previous video and this video. So let's talk about the last property. So we're always used to seeing positive powers so far, unless you're in a higher grade and you've already seen negative powers, but that's what I'm going to get to. So what if we had 2 to the power of negative 3, right? We've talked about 2 to the power of 3 quite a bit. What if we had 2 to the power of negative 3? So no panic, there is no need to panic. This is something we can do. So I'm going to do it and I'm going to show you what I did, or you might actually pick up on what I did right away. So this actually I can write as 1 over 2 to the power of 3, which I can write as 1 over 2 to the power of 3. So this is how you would solve it. Now I'm going to explain what is happening here. So we don't like a negative power. No one likes a negative power. Well, yeah, I would say no one likes a negative power. But So what do we do to get rid of a negative power? What we do is we flip the number. By flipping the number, I mean we take its reciprocal. And to get a reciprocal, all you have to do is put 1 over the number and you'll get a reciprocal, or just flip a fraction. That's a reciprocal. So what's the reciprocal of 2? Again, if it's a whole number, the reciprocal of it is just 1 over that number. So 1 over 2 is my reciprocal. And guess what? As soon as I flip the number, my sign on the exponent also changes. So in this case, it was -3, right? But as soon as I flipped it, which became 1 over 2, or a half, I can write that as a positive power, +3. And now, if you know exponents, an exponent is applied to everything in the bracket. So 1 is in the bracket, so is 2. So I apply the 3 to every single thing in the bracket. So you might see I didn't write 1 to the power of 3, I only wrote 2 to the power of 3. The reason I did that is 1 to any power is 1. It doesn't matter what the power is, 1 to any power will always be 1. So I didn't apply it that way. Let's do a trickier example with a negative exponent. Trickier as in you just haven't seen it. It's not that it's actually tricky, it's just you haven't seen it maybe. So let's say we had 3 over 2 to the power of -2. Again, I have a negative power. Well, what do I do then? Well, again, you flip the number, take the reciprocal. So how do I flip this? Well, you literally just flip it. Well, don't flip the whiteboard or whatever you're writing on, just flip the number. So you have 2 over 3, right? I flipped it. And now my exponent becomes positive. And exponent rules, I have to apply this to everything in the bracket. So 2 squared and 3 squared. So what's 2 squared? 4. And what's 3 squared? 9. So 3 over 2 to the power of -2, what I did first was I flipped the number. So 3 over 2 became 2 over 3. So that also in turn gave me a positive exponent to deal with. And then what I did was I just brought the exponent in. Whenever I'm bringing an exponent in, I apply to every single thing in the bracket. So I brought it into 2. 2 squared was 4. And 3 squared was 9. So whenever you have a negative exponent, flip the number, or more specifically, take the reciprocal. Reciprocal is just putting it, if it's a whole number, just put it over 1. If it's a fraction, then just flip the fraction. That's all you need to do. So if you see a negative exponent, now you know what to do. So I have a couple of questions in front of me that I'll go over. They're simple exponent problems. We should be able to do them with the properties we've learned. Let me just get rid of this. So, do notice that in the problems that I'm about to do, they are not in terms of numbers, they're in terms of x's and y's, but the rules are still the same. So you have x to the power of 2, y to the power of 5, being divided by x and y. Okay, great. So you have two variables here, x and y. And if they're two different variables, don't attach them together. Don't do anything with them together. Just treat them separately, and your final answer will be have them separately as well. So we know one of our exponential properties. When we're dividing exponents, there is no exponent here. Notice x to nothing, but there is a 1 there. If there's just an x or just a number like 2, there's always a power of 1 there. So in this case, there's a power of 1 there. So we just don't see it. So whenever we're dividing exponents, remember, we subtract the exponents. Or whenever we're dividing two of the same bases, we subtract the exponent. So what's 2 minus 1? Well, 2 minus 1 is 1. So x remains the same. So we've dealt with our x's. You can even go ahead and, well, actually just leave it like that. You've dealt with your x's. Now you have y to the 5 and y to the 4. Well, what do we do with that now? Well, it's two bases that are being divided, and their exponents are 5 and 4, so we just subtract the exponents. 5 minus 4, simply 1. So the answer to this is x, y. See how simple that is? If you know your properties, if you're dividing the same bases, subtract. If you're multiplying, add. If it's power of a power, multiply, and if it's a negative power, flip it. If you know those 4 or 3 things that I just said, you should be good to do most exponent problems. So let's do one more exponent problem that I have in front of me. So let's say you had x to the 9 multiplied by, well actually, maybe I'll write it like this, because my x's and my multiplication signs look very much the same, and most people have told me that. I'm working on it, I will get to it. So you have x to the 9, and you had x to the negative 7 up here, and you had x to 17 down here. Okay, so brackets just signify that there's some being multiplication. I could have put a multiplication sign there, that would have worked too. But whenever we have x's, we deal with brackets usually because multiplication signs and x's look the same for some people like me. But so let's deal with the top first, as in with any fraction. So we have 9 and negative 7. So we're multiplying two of the same bases, right? So when we're multiplying two of the same bases, as I've said countless times before, we just add the exponents. So what's 9 plus negative 7? Well, if you know your integer laws, 9 minus 7 is what it turns out to be. It's 2. So on the top we have x to the power of 2. And now on the bottom we still have x to the power of 17. So how else can I write that? Well, I'm dividing two of the same bases, right? Again, if I'm dividing two of the same bases, what do I do with the exponents? You got it? You subtract them. So what's 2 minus 17? Well, 2 minus 17, that's going to get me a negative number. Well, we now know how to deal with negative numbers, so we don't have to panic about that. So 2 minus 17, if you go ahead and do that, it's actually just negative 15. So my final answer is x to the negative 15. Now, we don't like negative exponents, right? And we don't need to panic if we see them, because now we know how to deal with them. So what we do again is when we have a negative exponent, we flip the number. So in this case, we have x. So what's the reciprocal of x, or what do we do to flip it? If it's a number, as I reminded you, just put it over 1. It'll work out perfectly. And you might want to put that in brackets. And now you have a positive exponent. That negative 15 is now gone. So if you want to be even more fancier, you can bring that 15 in. 1 to any power, again, is 1. And x to the 15 would be your final answer. So again, went over a few integer properties when you're multiplying the same bases, when you're dividing the same bases, when it's a power of power. So if you know those properties, you should be good with exponent problems. So I went over some very easy ones here, but actually with the laws that I've shared, I think you can solve any exponent problem. If you want, I can do a few more exponent problems from a worksheet that I have. I can do a few of the harder ones. Well, harder ones as in there's just more to do. It doesn't matter. I mean, there aren't new properties. It's the same properties. So I'll do a few more if needed. And in the next few videos, I'll talk more about exponents. I'll even talk a little bit about logarithms and what those things are. But I hope these are helping, and I hope now you know a little bit more about exponents, and you can do some exponent problems at home or whenever you want to do them.